So this talk is content management for Halo 2 and beyond, also known as Containing the Flood, since Microsoft always likes to have us have a subtitle for our presentations and games. I'm Mat Noguchi. I am the tools and sound programmer for Bungie and for Halo 1 and Halo 2. So, before I get into the main meat of this talk, I'd like to go have a slight little discourse about what exactly Halo is. As a game, Halo is a world simulation. What that means is, instead of trying to go ahead and force this rigid gameplay structure onto the player, we give them a sandbox and a bunch of toys and pretty much let them define their own gameplay. What this means is that basically we treat the player as another input into the game state, which means that ultimately you don't even need the player there to run the game. So what you can do is basically you can actually go into the shipping game and completely remove the player from the game and still watch everything unfold. So that's what one of our fans did, David Galindo. This is a video that showcases some of the Marine and Covenant battles using a couple glitches in the Halo engine that allows you to sort of watch these battles unfold without the Master Chief in them. And so this is from Cairo Station as the Marines are in that very first room, as the Marines are fighting the Covenant. Just to give you an idea of the kind of approach we take for Halo 2. So, it's in the front lines, David Galindo, halo2.vertigogaming.net. So, in order to even attempt this kind of approach to game design, you not only need sort of a really high level of detail, but a wide breadth of detail as well. What that means is you need animations for every possible action any character can take with any vehicle. It means you need to have effects for every material versus material interaction, from a plasma bolt hitting rusted metal to rocks falling in water to the warthog skidding on the beach or metal grinding against metal. It means that everything that looks like it should make a sound should make a sound, and that every sound has to have enough permutations so that the player will not hear repetition. It means that our AI system needs to be able to handle pretty much any situation given to it, and that for combat dialogue, that any AI entity can say anything to any other AI entity. In other words, we need content. Lots of content. Now, these are figures from Halo 1. The number of files sort of represents the diversity of content, and the size just represents the physical depth of the content. So this is pretty reasonable for Halo 1. I mean, we had no idea what we were getting into, and we just sort of said, let's throw as much stuff into the Xbox as we can, get a game out for launch, and see what happens. So after that happened, we shipped who knows how many games, and we decided to work on Halo 2. One of the things that we did not anticipate in the end for Halo 2 is just how much bigger our game would get. So Halo 2 was almost 40,000 files, 11.6 gigabytes of space. And the most surprising number out of all this is that sound went from 800 megabytes to 7,500 megabytes. And not only that, but our animation sizes kind of exploded as well. So in order to continue doing this sort of sandbox gameplay environment, the amount of content you need is just going to get bigger and bigger. And eventually, if you aren't able to handle it, it can crush your game development process. In fact, because our sound database was so big, at several points during the development process, we had to re-architect how we loaded files and stuff like that, just to make sure that everyone could keep working with this giant deluge of sound. So the question is, what can we do about it? Well, since this is a programming talk, we as programmers are the ones that can take care of this. And the way to do that is content management. So what is content management, aside from the point of this whole talk? Content management is a process by which you create, organize, and access non-volatile game data necessary to drive a game engine. In simpler terms, it's how you programmatically manage game assets. Now, for Halo, we are fortunate enough to have a system in place to handle all our resource management called the tag system. Now, the tag system had its origins in myth as a cross-platform resource management system, but it has evolved extensively since then. At its core, our tag system is a set of interfaces and types that let us programmatically inspect and manage code structures. And so I'm going to give an example of how you would actually go about defining a resource that we would manage both in code and in our tools. So this is our sound environment. It defines a reverb for a particular room in a level. And in code, you would go in with a bunch of macros and lay out the tag group like this. And so once you've done that, you can register this tag group with the tag system, and this is how you would edit it in our editor, Gorilla. And these are the functions we use to programmatically access tags. The most important of these is tag get, because it lets us represent all our resources with a handle and a type. And this becomes, I'll get back to the importance of this later, but this basically is how we access resources at runtime for any system, from AI to physics to rendering to sound to pretty much anything that someone besides programmers is going to have to edit or create. So the second construct we have is called a tag block, which is similar to a tag group in that it lets you define arbitrary C structures, and it also represents a resizable array. Now, since both tag groups and tag blocks can contain tag blocks, we can pretty much represent any structured data hierarchy possible. And so this is how we would use this. So this is our camera track tag. We have camera control points and a block of camera control points embedded in the camera track tag. And this is how we would define it in code, or define the schema in code. This is how you would actually access elements in code. This is a pretty ugly macro, but you can hide it behind, further macros or templated code. So this really isn't that big of a deal. And this is how you would actually go about editing tags in Gorilla with tag blocks. And so we have just this one generic interface for adding, removing, inserting, deleting tags, tag block elements. And so using the tag group description, we can easily translate our resources between both binary and text representations. We didn't do this that often, but it helped a lot towards the end of the project as we were locking down the content database. We wanted to know, which designer went in and changed the dash distance for the energy sword, or who was the guy that nerfed the needler. And so this really helped us out a lot. We actually had an intern go in and integrate this process into our check-in system so that you could, at any given point, look at a history of a file and see all the changes right up front without having to load any other tools. So the last abstraction we have for our resource system is called a tag reference, and this lets us explicitly define external references for our resources. This is nice because it encourages design of content through composition. We try to build things from the bottom up. First, if we were going to make a model, you would create the render model and then attach shaders which would reference bitmaps. And you can share bitmaps between any different shader and share shaders between any different model, and so on and so forth. This is how we would use it in code. This is the item permutation, the item collection tag. This defines what weapons or items spawn at a particular location in a multiplayer map. This is how you would use it, define the schema in code, and this is how you would go ahead and edit the tag in Gorilla. And so I apologize for the really shitty display, but this is the tag reference, and we have a few buttons that this button lets you edit, change what tag it is. The button next to it lets you open it so you can, recurse down a hierarchy, and there are a bunch of other buttons that don't really matter. So anyway, with the tag reference, we can use this graph for many different. We have an explicit dependency graph that we can access at runtime. And one of the main uses for this is loading tags. So what we do if you want to load, say, the Warthog and all its dependencies, you load the Warthog, you look at its dependency graph, you start visiting each dependency in depth first order, load those as you go, and by the time you get back up to the root, you have all the data necessary to load the tag. So we use this kind of dependency graph to create the variants for the Warthog. Instead of baking in the two different turrets for the chain gun Warthog and the gas turret Warthog, we actually modeled those separately and attached them to the object so that, you could change what kind of variant you had at runtime. And this also turns out to be the main way to hack Halo on the Xbox. People can go in and directly modify the tag references in the map file, so you get stuff like this. You have the sniper rifle that can shoot ghosts, all sorts of crazy stuff. And so one of the nice things about having our tag system is that we remove the responsibility of loading resources from all these game systems like AI, physics, rendering, and sound. And so in order to make sure that all the different game systems have the resources necessary to run the game, we load all our data from two tags. One is called the globals tag. It has all our global data, things like falling damage, how that affects the players, various AI parameters, the grenades you can use at runtime, the weapons available in multiplayer, stuff like that. We also have a scenario tag, which defines the level-specific data, things like AI encounters, the vehicles you're going to use to run that level, the scripts, the various trigger volumes that hook into scripting, things like that. So this gives us a single entry point for loading a level, which is really nice when we're trying to do load a level for gameplay, for light mapping, for generating our final build, for analyzing various aspects of the level, like how many bitmaps did you load, how many animations did you load, what kind of materials do you need in order to finish this level, things like that. Unfortunately, occasionally tags get integrated into a level and then they get forgotten. So this is how the engineer got into Halo 1 and the Flood Juggernaut got into Halo 2, because somehow they got put into the game, and then we didn't have anyone go back and scrub it, and then all of a sudden you have, 2 days after launch, people go and say, hey, I'm going to go hack Halo. Hey, look, I found this giant monster. What is it? Ooh. Things like that. So that single level loading process is great, but it's the only fully supported mechanism we have to load tags. And so we've had to go in and insert workarounds so that, if you wanted to just work on the Pelican, for example, instead of creating your own level, going into our editors, and adding the Pelican, and then having to load that on the Xbox, all you have to do is load your level on the Xbox that you want to run around in, go to our cheat menu, and drop the Pelican. And so this uses the same process to load tags as the scenario does. So it'll load the Pelican and all its dependencies so that you can iterate on it, run around with it, stuff like that. Now, we can also use our tag loading process to replace missing tags at runtime. This turned out to be really helpful because of how complex our data hierarchies can get. A lot of times you have people working on, objects, models, things like that, and they have this beautiful, beautiful model that they're working on, but they forget to check in, 5 or 6 different parts of it. So instead of either not showing that thing when you try to load it or simply crashing, what we do is we say, in this particular case, for objects, if you don't have the object, we replace it with a dummy object. This happened quite a lot. In fact, towards the end of Halo 2, one of our maps, Zanzibar, had a bunch of palm trees off on the beach that weren't ever checked in. And so whenever you play, you see these 2 giant spheres right there. And it's like, what the hell is that? And someone go and say, oh, yeah, I forgot to check in the palm tree. Oops. And so that's great if you're trying to modify runtime behavior, but increasingly we found that, especially for really anal art leads, they want to know, hey, who's not been checking in all their resources? Who forgot to add the palm tree? Who moved a bunch of files around? How come when I try to shoot the shotgun, nothing happens? And so what we can do is, using that dependency information, we can load all the tags in our game, all 39,000 of them, figure out their direct dependence, and then generate a graph from that, and then take a look at every single node that's missing, and figure out who is pointing to those nodes, and then generate a list of tags that have dangling references. And so in this graph is listing out all the missing tags that I have on my box right now. And so what you can do is you can say, hey, I want to remove this reference, or you can even say, it'll give you some suggestions of what the new tag you should be pointing to is. Or you can go in and just say, hey, I know what this should be pointing to, and go do that. So this was really helpful as we were transitioning between Halo 1 and Halo 2 because we decided to completely change how we organized our data in folders. And so instead of having to go in and manually open up every single tag and say, all right, now this tag points to this tag points to this tag. Oh, objects are no longer under vehicles Warthog, it's under objects vehicles Warthog. We created this automated tool that would go in and do all this work for us. And so another thing that we can use the dependency hierarchy for in our tools is to duplicate or move assets around the file system. Now, the naive way of duplicating a giant hierarchy of tags is to just, do a simple file copy. Now, the problem with this, with our system, is that you're still going to have dummy references back to the original data hierarchy that are no longer valid. But if we do this through one of our tools, we actually have the information necessary to repoint all the references back to the files we copied. And so everything becomes happy again. And so we can do this to either, duplicate entire hierarchies or to just simply move data around. If you have to move data around, the process becomes a little bit more complicated because you have to fix up not only these references internally, but you have to fix up all the external references to this particular group of data that you're changing. And so because we have a generic system to handle all our resources, we can actually, and we have, handles in order, you have to have a handle to access data in a tag. We can go ahead and reload our assets at any time. So now I'm going to give a demo of that and how a designer would go about modifying what I would consider to be a pretty whippy weapon, the Needler. So this is our editing tool, Gorilla. This is what allows us to edit various content in our game. This is the Needler tag. So I'm going to go ahead and drop this in our game using the same mechanism that I showed you before. And hopefully it'll be right there. So there we go. So here's Needler. It's very simple Needler. It doesn't do much. It's kind of like a giant Covenant pea shooter. So let's say that I'm a designer. I'm feeling a little, crazy. And I want to make this weapon a little bit more powerful. So what I can do is I can go back to the tag, modify a single field. So anybody have any suggestions for a projectile we should attach to the Needler? All right. Well, we're going to go ahead and add the fuel rod gun projectile. Save that. Copy that over to the Xbox. Hopefully, there we go. So now we have a much more powerful Needler. Now we can do this with pretty much every single piece of content in our database. So let's try that with the shotgun. So let's go ahead and drop let's drop a shotgun this way. Go pick up the shotgun. And what do you think would make the shotgun just a little more dangerous? Well, since we can attach any projectile we want to it, let's go ahead and let's give it some rockets. Save that, sync that over. Here's our lowly shotgun, attempting to blow up a Warthog. About 5 seconds, I'll actually be able to do that. So this is really nice because not only does the tag reference allow us to pretty much associate any types of data with any other types of data, it also lets us, completely change around data hierarchies and view them in real time and update and view them in real time. Now we can extend this system using we can build on this system to make our artists' lives even easier. So let me go ahead and sort of demonstrate how Eric, one of our vehicle and object artists, would go about go iterate on an existing tag. So here's our Warthog. It's been specially designed for this talk. As you can see, it's more sporty. It's got a spare tire in the back, in case you have a flat tire. And so let's say we want to go ahead and give it a new paint job. So we have a tool called Monitor Bitmaps that uses some of the Windows file monitoring functions, mainly read directory changes W, so we can track all the changes that happen to a particular bitmap, re-import it, and then sync it over without the artist having to do anything except save the bitmap. So I'm going to start that now. Let that get initialized. So what this is doing, it's setting up the file monitor so that it'll be notified every time that this particular, wow, that's bad. Let's see if it, I'm going to fix the color so you guys can see the changes I'm making. And let's just set this back to default. There we go. All right, so here's the default bitmap for the Warthog. And let's say we want to give it a new paint job. So we can go in and start painting over and updating the color. Yada, yada, yada. And then all we have to do to see these changes in the game, once we have monitor bitmaps running, is save this tag, save the bitmap. The monitoring software will eventually pick up the changes and report the tag. And all this, now this is normally faster on our artist machines because they have a lot more memory, much better hardware. But yeah. So it should happen right about now. So here's the new, brand new spanking yellow Warthog that you will never see unless you hack your Xbox. And so what's nice about this system is you don't really need any particular picture editing software. I mean, you can use anything. We can even use Microsoft Paint to go in and edit this tag and see the changes happen on the Xbox. So let's go ahead and do that. Go ahead and save that out. So this should update pretty quickly. Now the artist, we added this feature at the end of Halo 1, and the artist immediately started using it to iterate on bump maps, textures, diffuse maps, things like that. And it became so popular that we actually integrated this kind of functionality with our modeling. So whenever you export data from 3D Studio Max for levels or models, or I don't know if we did this for animation, but it would pick up the changes, sync them immediately so that artists, instead of having to manually go in and update the entire state of their box every time they made a change, they just had to do one thing, and that's edit the file and save the file. So that's all the demos you're going to see today, unfortunately. And so another thing that we can use our tag system for is to optimize our data for our shipping builds. Now this is how our tags would get laid out in memory if you're going to be loading them for editing. This is how you would look at it in code, how you sort of visualize it in code. This is the layout you would have in memory. Now those gray little blocks right there sort of represent the overhead of the memory manager to track all these heap allocations. And so what we can do is actually, because we have the tag layout, we can actually go in and walk all the loaded tags after we've loaded a level and actually stream out that memory in order into this one giant flat file. And then when we're running on the Xbox, all we have to do is load this into memory, and then reference it using tag get. Now this is how we ship for Halo 1. This is how we ship for Halo 2. It's extremely powerful. It lets you load tags very quickly, very easily. You take out all the overhead of trying to allocate your resources piece by piece at runtime. So it was extremely helpful for us. Another thing we can do because we attempt to keep a read-only view of our data for all the game systems, we can actually go in and find duplicate data and start aliasing pointers as we're writing it out. And so for Halo 2, this happened to save about 1 meg per level because we had a lot of different tags that all had pretty similar values for things like functions or tag references or shaders. They all had pretty much a lot of the same data a lot of the same binary data throughout the tag. And so, in memory, these pointers are aliased, and because you can't modify them, it doesn't matter that you have 15 pointers pointing to the same thing as long as the data view remains valid. Now, another thing we can do is take all the code fields that we need in our editing build in order to actually edit the stuff at runtime and go ahead and strip this out. This turned out we didn't do this for Halo 1, but it turned out to be a pretty necessary step for Halo 2 because we're running up against some severe memory budgets. And so as we're streaming it out, all we do is just strip out those fields as we walk along the tag hierarchy, and then it just compresses the tag like that. So as powerful as our tag system is, we did have a few problems with it. You can sort of classify these problems into two separate areas: problems of design and problems of scalability. One of the biggest problems with our tag system is the fact that our tags are mainly direct views into code structures. And so programmers think a lot differently from artists. And so what happens is you have this kind of explosion of fields that you can modify. And for example, this is our model tag that has, and this is one of the variant blocks. And honestly, I have no idea what half this stuff is. And basically what happens is, as a programmer decides to add new functionality, instead of attempting to figure out, hey, what's the best place to put, new fields, new tag blocks, new information, they just kind of append it onto the end of the tag. And so you got a whole bunch of just stuff in the tag that's laid out in no particular order, which makes it very, very difficult for a designer to go in and say, hey, I need to modify the new damage targets for the Warthog so that, it can blow up. And so it takes a lot of back and forth between the programmers and designers to actually come up with a good interface for that. And so one of the other problems that we ran into is based around versioning, or pretty much the lack thereof we had for our data. So back in Halo 1, in order to properly version a tag, what we would do is insert a lot of padding in the middle of various C structures in case we needed to add new fields to it. So, for example, our shader tag would have 15 D words of just padding space in case we need to insert 15 more floating point values for future expansion. With Halo 2, we actually added a very, very limited support for versioning. So this useless padding became pretty much unnecessary. But we never bothered to actually go back and correctly update old tag formats. And so on 2 occasions, me and a few of the lead programmers had to actually go in and just start ripping out all this useless padding. And so fortunately for us, we had the tag group layout, which let us annotate all the fields that were useless padding. And so we could go in, load up all that data, strip it out, compress the tag files, and then write it back out. We had to do this once before E3 2003 and again before we shipped. I'm not sure how much data this actually saved before we shipped, or before E3, but when we shipped, it saved about 300 to 500K per level. And so basically, our tag system not only caused a big problem for us, but gave us a very basic solution for that. And so another problem that we ran into was our combat dialogue basically destroyed any workflow we had set up. This was for several reasons. The first one being we had, as you saw before, just an incredible amount of combat dialogue. We had about 45,000 sound tags for about 20,000 lines of dialogue, which took up about 4.5 gigs of data. And this was bad not only because, it's a huge amount of data, but we had actually, for every sound tag, we put in the localized versions of that data into every single sound tag. This was so we could have an easier time localizing. What it meant is for every sound tag, in order to actually load the data necessary to use that sound tag, you only read a tiny bit of data, but that tiny bit of data was interspersed throughout the entire file. So what would happen is you'd load up the file, and Windows would say, hey, you're loading up 150K sound file. Let me start paging in data for you. And then you'd read the first 200 bytes, skip down about 50K, read 4 bytes, skip down 50K, read 4 bytes, and Windows would say, oh crap, I got to flush all that data. All right, now let's start reading in some more. Oh crap, I got to flush all that data. Start reading in some more. Oh crap, I got to flush all that data. So this, of course, led to problems because our combat dialogue happened to be in every single player level. And so what would happen is whenever you're loading the level on the PC in our game editor, Sapien, you would have these tremendous load times on the order of 2 to 5 minutes. Now that may not sound like a long time, but when you're in a development build that happens to not necessarily be stable, it crashes a lot. Or you have to reload a lot, or you have to get new versions, or basically you spend a lot you're going to spend a lot of time loading the data. And so this impacted everyone so much that that our only solution was to go in and say, all right, for 90% of the people that don't need to use sound, you're going to just have to not get it. Don't map combat dialogue from our source control system. Don't bother with it. It's way too much data. This really isn't a solution. But the main reason this happened is because our tag system, as we're saving out tags, it's designed to be a single pass when you write them out. And so because it's single pass and we didn't really understand the ramifications of that, we had these giant blocks of data that would happen to have a whole bunch of binary data, but very little control data. So as it's writing it out, it would write out the tiny bit of control data, a lot of binary data, and then another piece of control data. And so this wasn't a problem for Halo 1 because you could pretty much fit all our dialogue into a 2 gig machine and not have to worry about it. But as we're moving on to Halo 2, you suddenly have 4 gigs. No machine out there can load a Halo 2 level without thrashing a little bit. And so one of those problems that just kind of crops up as you start throwing a ton of data at your system. So obviously, I think content management is the next frontier in game development. We've found that we've had a lot of content, so we've had to actually explicitly work on this problem. This talk went a lot faster than I had anticipated. So are there any questions? Anyone? Technical details? Feel free to come up and ask them. Go ahead. Yeah, so we ran into a couple problems. So the question is, read directory changes W will notify you of every single change that will happen to a file, including writing to the file, opening the file, the name changes, but it doesn't actually let you know when the file's closed. So we ran into that problem twice, once with our antivirus scanning software, which would open the file every time it got written to. So what we would do is just sort of spin on the file until we got access to it. It's not really that good of a solution. A better solution would be to actually use the NTFS change file journal, and that will give you a notification every time reference to the file is closed. And then you can go back and say, all right, once a file is closed, I can go ahead and open it and mug with it and close it and be on my merry way.
So what was the mechanism for exposing tags into your editors?
Okay, so the question is how we would go about taking the tags and exposing them in our editor. So that, way back in the beginning, I showed you the tag schema that we define in code. We actually have a giant list of available tags available for anyone to edit. And we do this manually simply because it's easier to manage that way. And so in this case, we would go ahead and take the item collection tag group, put it into this giant list, and then Gorilla would link in the game and then say, all right, these are all the tags that I can create. We actually link in the game engine. And so the game engine has this list, and we just query that list. And so here are pretty much all the different tags that you can create. One giant list. More questions?
Is your data already self-contained? Like, don't have cases where, depending on the game context, you need to load in data?
So the question is our data self-contained, or depending on the context, do we try to load in different data? For Halo 1, we did have several. For combat dialogue, we didn't integrate combat dialogue that well into our tag system, so we did actually have to repoint the tag directory to a localized branch if we're building for different languages. For Halo 2, we wanted to be able to support not only, we wanted to be cross-language. So we made sure that every data that needs to be referenced is referenced through either some chain in the globals tag or some chain in the scenario tag. And so what would happen is you would occasionally have to load data in that wasn't necessary for that level. So we'd added a custom process after the level's been loaded to actually go back and strip out all that data. So it's more of we load everything at once and call out what we don't need rather than trying to retarget what we load on the fly.
Was there any integration of your content management tools with version control software?
Yeah, the question is, did we integrate any of our content management stuff with source control management? So in Gorilla, we actually integrated this originally with SourceSafe and then with an internal Microsoft source control system. And that whole graph I showed you with move to, copy to, if you choose move to, it'll actually go ahead and check out all the data that needs to be modified. Go ahead and move it, and then give you a change, basically a description of all those changes that got made, so you can reintegrate that back into source control. I mean, that was one of the reasons why we went ahead and made this tool, so that we could, at any point in time, completely move data around, copy it, rename it, what have you, and still have source control, the version in source remain stable without too much overhead on the part of artists or programmers. That guy with long hair. So the question is, do we have additional customization for our loading process? Is that correct? Right. So I stripped out a lot of the information, a lot of the declaration of the tag group, but we actually do have additional extensive functions that we pass into that definition because, obviously you're going to want to change behavior of data as it gets loaded. So we have functions that allow you to customize. Basically, you get access to the tag after it's been loaded. So you can say, all right, let's say you have a shader tag. I want to go in and take a look at all my bitmaps and figure out the biggest dimension of that, and then store that somewhere in the shader tag itself so that I can use it later for runtime. So we do have those hooks into our code. That's both a good thing and a bad thing. The bad thing about having custom code for loading is that it creates dependencies between tags that you can't really track through the data itself. This turns out to be a really big problem if you ever want to go ahead and extend the editing interface. So let's say you want to go ahead, edit the tag in real time so that when you're typing in new values, those values get propagated immediately without further intervention from the programmer or artist. What you would have to do in cases where you have custom loading code is you actually the easiest and most correct way of propagating those changes is you're basically going to have to reload all that data and reprocess it and run it through the reload process. if you didn't have any custom post-processing code, you know ahead of time that there isn't going to be any behavior change if I just modify this value. So it's both a blessing and a curse. Are you referring, so the question is, okay, so we use that same, the question is how we deal with duplicate texture data. So let's say you took the warthog and duplicated that entire hierarchy and then loaded both those, the two separate warthogs into memory. Is that correct?
Yeah, well, we use save them down in an optimal way.
Right. So in the case of binary data, we have we use the same duplication detection process. So if you have 15 textures that all have the exact same binary layout, I'm talking about the raw sample, the raw pixel data. The references to all that pixel data will get combined into a single reference. It's similar to COMDAT folding, where identical pieces of code will all get merged into a single piece of code, and you'll all point to the same thing. Mm-hmm. Right. I'm kind of confused as to the question. Do you want me to go back to one of the slides to? Oh. So when we optimize our data, we are never going to edit again. It's just there for the final version of the game. And so we can do these crazy tricks like merge duplicate data. We did have a step at one point that would actually analyze the entire data stream from the beginning to the end once you're adding in new data. But we took that out because it was an incredibly time-consuming process. He had a question next. The question is, we kept a lot of our data read-only. Did we need any workarounds to maintain that? We actually did have a few systems that needed to modify tag memory. The major one was Havoc, because they had a completely separate data model compared to what we had. And so we would actually mark sections of the giant flat file as modifiable at runtime. So they could go in and say, all right, I'm going to mug with this vtable pointer. And there was another question over here. Are you referring to, so the question is how we go about predicting assets for the next level. Are you referring to how we know what to load next inside a particular level, or how we know what the next level is going to be? So inside a level, we have a caching mechanism that takes a lot of the bulk streamable binary data like textures, geometry, and sound. And during the cache build process, we just write that all out. And so when we're attempting to run the game and we need a particular piece of data, there is a few visibility prediction calls based on prediction that happens based on your location and just walking through your potentially visible set. But most of the prediction happens through scripting. So let's say, the designer knows that it's going to place an encounter. The designer would go in and say, predict the 3 separate enemy characters that are going to appear as you turn this corner. So it's partially code-driven, and it's also designer-driven, because designers know what's going to happen more than the code ever would. More questions about anything? Go ahead. So the versioning we support right now, Oh, sorry. The question was, what kind of versioning do we support? It's a very, very simple versioning. So, for example, if I were going to version the tag group, all I can do right now, well, there are two ways of versioning. The simple way of versioning is to go ahead and just add on a field at the end. So let's say I wanted to add a real integer or a real number to the end of this tag. I do field real, blah. Compile, link, and it'll show up. Any tag that was saved before this version of Gorilla will have this new field magically appear at the end. We also have an explicit versioning mechanism that lets you take an old version of a tag, or two versions of the tag, and then define a fix-up procedure to go from the old one to the new one. And that turned out to be a source of a lot of problems because we didn't rigidly define that mechanism. So as we're adding new fields, adding new types, we didn't take into account the complexity of that system. Because it was sort of tagged on to the existing Halo 1 system, which had absolutely no support for this. And so the idea was to be able to load Halo 1 tags and load Halo 2 tags at the same time. And so we didn't go in and revamp the file format, so we did have these problems with versioning. It also means that we had code-dependent data as opposed to code-independent data. So there were a lot of times where you would have tags that were checked in and you'd have a different version of the code. And so you'd load the data and it would trash, the second half of a tag, like the scenario tag or a weapon tag.
What changes do you expect to do in the future?
So the question is, what kind of changes we expect to do in the future? The most important changes that we are going to be researching are going to be centered around presenting a more friendly view in Gorilla. Like I said before, this kind of interface sucks because all the data you want to look at is hidden in between data you don't care about. So that's one avenue of research we're going to go down. I mean, it should be pretty easy, straightforward for us to do this, to separate sort of the data representation from the visual presentation. We already do this a little bit with our level editor, Sapien. But yeah, we're going to try to extend that sort of approach to editing to Gorilla as well. We're also going to, because a big source of problems for us was versioning, we're definitely going to have to revisit that and figure out a system that is 99 to 100% programmer proof. And then there are a whole bunch of other things that I don't think I'm allowed to talk about. But the nice thing about our tag system is we can make all these changes orthogonal to the rest of the code. I mean, that's just a blessing a million times over. We've had to change the back end of our tag system, where it reads from on the Xbox at least twice, and we were able to integrate all those changes without affecting any other system. Any more questions? In the back. Sure. Are you talking about the horrible numbers? This one? So the question is how we handle editing per instance properties on objects. I'm assuming you mean things like vehicles or characters?
Yeah, if you have more than one in the level.
Right. So our level editor, did you get all your data down? All right. So anyway, we had the scenario tag has the list of objects that are going to be instantiated in that level. And so that's where we put all the per instance data. And that's the tag that we use in our level editor to go in and determine and to present the designer with the view of the level and allow them to add types, add objects, edit objects, things like that. So we have sort of a two-tier separation of data there. We have the object definition, which is a template, basically a template, and per instance information in the scenario tag. You first, then you. So the question is, if I understand, who tracks the changes in the source control and who manages that whole system? We don't actually have anyone right now that does that, and that turned out to be a real shortcoming during Halo 2's production. So that's another area we're going to be looking into, but that requires less technical finesse and more just people finesse.
Again, with the instances you talked about, I mean, how do you do some kind of overrides or something? So like you have some small properties you want to change per instance, but then you want to keep a lot of, I mean, the main data you want to have like the prefab and the instantiated multiple times and change that and the prefab and all that from the prefab constantly instantiated. So then you have some overrides or something like that.
Oh, so if I understand the question correctly, is how we manage the overriding of the object template tag per instance. That is mainly programmer driven. We basically someone listens to the demands of the artists or designers. Occasionally, the programmer listens and says, all right, I'm going to just add these fields to the instance definition in the level tag. We don't have any formal or automated process to do that. It's mainly driven by the desires of the artists and designers.
Okay, so those properties that are in the instance, they're not in the normal.
Some of those fields are not available, things like position and rotation and orientation. But a lot of them are somehow defined by the object tag. So things like change colors, which define how an object appears, or which variant you use. You can create the variant that you're instantiating the object with. You define that in the instance, and then the object itself has a list of variants that it can instantiate. But there's no magic to that. It's just making sure that the programmers and designers are in sync, and that the designers have all the data necessary to build their levels. Any more questions? All right. Well, thank you for coming.